Hi everyone and welcome back. I want us to look at natural language processing. And natural language processing is the application of technology and computing to train the computer how to understand human language. And there are a lot of applications for this that can be used, including sentiment analysis, text classification, machine translation, and question answering systems. And these are just a tip of the iceberg. There are so many other applications of natural language processing. It's a very interesting area, and models such as ChatGPT, which are called large language models, are a part of the natural language processing. So of late, the NLP has taken quite a bit of interest around, and there are so many applications. Now, for this, I want us to use SpaCy. Now, SpaCy is a very good open source system or library in Python that is designed to process large volumes of data and also includes a lot of pre-trained models that we can use and take advantage of. So we'll be using SpaCy for this learning or this segment of natural language processing. Now it's very easy to install SpaCy. You just need to Google how do I install SpaCy and it will bring you to this page. And then you'll find all the installation guides there. I'll include this link in the description that you can just use and go ahead and install it. For this first video, we are going to do a text classification using SpaCy. Specifically, we are going to do sentiment analysis. Now, sentiment analysis is also called opinion mining, and it's classification of text to be able to extract the opinion and the attitudes that people have towards a specific topic or a specific product. Now, how we do that, we have a data from Twitter that we have been able to generate. This is how the data looks like. So there is the text itself, and then there is a sentiment, which can be either neutral, positive, or negative. Then there is now the language. It can be Swahili, it can be Sheng, it can be English, it can be all the other languages which are classified as others. And then for the type, we have mostly that whether it's an advert or it's a normal text. This is the data we are going to use. You can ignore these two. We are just going to focus on the sentiment. So for each tweet, we are going to look at, is it positive, is it negative? That's it. The purpose of this video is not the coding part, it's the application of SpaCy. So I've already pre-written some of this code, and we are just going to go through it and be able to explain what was the idea here. And then I'm going to share the code on GitHub so everyone can have access and can be able to replicate what I've done. And I've imported some libraries, which is Pandas OS. I normally like to use OS for extracting the way the information is coded within my local file. And from there, I've read the dataset, which I've showed you, which is the Twitter dataset. So under that folder dataset, there is the sample Twitter data. Now, this is the way it looks like. We have the tweet, we have the sentiment, the same way I showed on Excel. We have the language and the type. So we said we'll ignore the language and the type, and are only going to focus on the tweets and sentiment. So once you've read that data, you move on. This one is just showing the number of nulls. They are very small comparatively speaking. So we'll remove those ones. Now we need to remove the mentions, and we also need to remove the hashtags from the Twitter data. So how we do that, we import punctuation, which is going to help us clean the data a bit. We then import the tweet tokenizer. We want a specific tokenizer to be able to break down the tweet into specific words or specific sentences. In this case, we're going to use word tokens. And then we also need to use re. Re is a way of using regex in Python, which can be able to extract some patterns. NLTK is the natural language toolkit in Python, can help you work with natural language and be able to clean it better. And once we have that, we also import the punctuation, which gives us all the punctuations in English, like exclamation mark and hyphens and so on. So we create a list of those punctuations, and then we initialize the tokenizer, the Twitter tokenizer. This function will help us remove the mentions and the hashtag, and this is the pattern that we need to extract for the mention, and this is the pattern that we need to extract for the hashtag. And then we go through the tweets, and then we remove them. And this is how we remove them. We apply the function to the tweets, and then we create a new variable called tweets cleaned. And I'll just show how that looks like. Um, yes. So this was the original tweet. And then now this is the clean tweet without any hashtag. There was a hashtag here, it was removed in the subsequent clean column. And you see there was a lot of mentions here, so there is nothing that is being shown here. And at the same time, this one, there was a lot of mention and then it has been cleaned. We're only seeing the text that we need without the mentions. So in this case, we are saying that the mentions are not important for the sentiment that we want to extract. So we move on with this. Now, the next thing is to remove stop words. Stop words in English are words like conjunctions, and what these words do, they give the position or they give some additional information, but they don't give some meaning. So, for example, when you say, I went to the market, the key thing there is that you and then the market. The went part is not so important. Yes, you went there, but the key thing is that you and the market, those are the two words that have the main meaning. They are very loaded. So we want to remove those because they have no indication or they have no meaning to the sentiment. So how you do that, you add all the stop words in English from the natural language toolkit, and then you add the punctuations that we had added. Added. I hope that is visible and can be seen. Let's see. So when we look at the variables, let's look at this. So for example, the punctuations would be the exclamation mark, the quotation marks, the percentage sign, the dollar sign. So those are the punctuations. I want to look at the stop words. So the stop words are words like I, me, myself, we, and those are the ones that we combine this and the punctuations, and that will give us the stop words. The next thing, we remove those and we call that the tweet clean version 2. And again, I'll show how that looks like. So we have less. You'll see that these words, the like on will be removed from this and others. Now, we only want to work with the sentiment. So I said we can ignore the other two columns. So we have the cleaned tweet and we have the sentiment only. Now, when you look at the sentiment, because this data was manually encoded, someone had to sit down and read through the tweet and say, okay, this is positive, this is negative. You'll expect a lot of errors. Like, for example, neutral and then neutral with a small n. So that's a repetition. Positive and positive with a small n. There is also some missing values. So how we do that, we clean it. So by just using capitalize, you can be able to remove, to make sure that this repetition is removed. So once you do that and then you remove the neutral, we don't want to work with the neutral for now because the data set is very small, and we don't want to confuse the model because some of the neutral are close to either positive or negative. Some people would consider them positives, others would consider them negative. So because there is a lot of subjectivity in this, I wanted just to get the extremes, which is positive and negative. Ignore the neutral. That is an important aspect of sentiment analysis. Now we are only remaining with positive and negative. So the data looks good. It has been cleaned. So the output column looks good. And the input, the tweets have been cleaned. We have removed the mention, we've removed the hashtags. So we move on. And here, what we are doing is we are creating like a JSON format or a dictionary where we have the data, tweet, and then that is going to be the tweet followed by the sentiment in a dictionary format because that's the format that SpaCy needs. We're also splitting the data 400, so the data had about 520 something. So 400 will go in the training. Down here, you see that training goes from all the way to 400, and then the testing goes beyond the 400. So we're also splitting the data into training and testing. And we are seeing that the test size is 25%. So 25%, which is 137 tweets, is going for the testing. The rest is going for the training. Now, how the dictionary looks like specifically, there is the key, which is tweet, and then we give it the text. And then there is a key, which is sentiment, and then that is we give it the positive. So that's the way the dictionary. So the list will be a list of a lot of dictionaries, small dictionaries with the key being the tweet and the sentiment itself, and the values being the text and the sentiment value. So there is a way that the data needs to be stored, especially for SpaCy 3, which is the most recent one. And how you do it is you once you've created these dictionaries and saved, and then you have this training list and you have this testing list, you need to convert it into a .spaCy format, which is the one we are going to use for training. Now, this one I just googled this function. So first of all, you need a library called docbin. You need so the space has been repeated. You need JSON format, and I think this one has also been anyway. We need to. This is repetition, so it has no meaning. Should have seen that. Then we are going to. So the categories are either negative or positive. We're using a SpaCy blank model. So we mentioned that SpaCy has a lot of pre-trained models, but it has also blank models that you can take advantage of. And what we are going line by line on the training and the test or the testing, and then we are converting the NLP make doc. So the main document will be the tweet itself, and then the categories will be the categories either positive or negative. So it's going to be able to recognize that. And once now we have that, we add that into an output file, or we save that to disk. So what we are doing here, we are going to convert the test data, and the output will be the input slash test language dot spaCy. It's a variable name, you can change it to anything. Then the training as well. So once we have that, I'll show you how that looks like. So when you look at the files, this was the Twitter dataset, and then under now the input, we have test language dot spaCy and train language dot spaCy. So we've generated two training data and testing data that we can use now moving forward. Now, finally, the interesting part, which is the model training part. First, we need to create a configuration file that we can use now for putting those settings or for tweaking the models if we see it fit. Of course, for this first model, we're just going to use it as is, using the default settings, but it's good to have this configuration file. And now from here, you can actually go ahead and use the terminal. But I'm going to use the VS Code because I want us to store this information that someone else can be able to use it. The terminal will not save this information, but you can use a terminal. So what you do, you write Python. The exclamation mark is because we're using a terminal command on Jupyter Notebook. And then we give it the name is SpaCy. We want to use the SpaCy module, and we want to initialize a configuration file. And this is from the pipeline text cut. And then the output file is the config.cfg. And once you've run this, it's going to save a configuration file on your local machine, which is this config.cfg. And once you open it, you'll see a lot of information that you can change, like the paths, the system, the NLP, and so many others. And you can find a lot of documentation on this online. So feel free to change whatever you see fit, maybe depending on the problem you're working on or on the specific domain. Once we've done that configuration file, we then need to train the model. So again, we'll say we'll use the exclamation mark to show that it's a terminal command, Python, then minus hyphen m, and then SpaCy. We want to train the model, and we are using the config.cfg, the file we've just created up here. Then we give it the path. So the path for training, so path.train, we give it the training file that we created. So inputs, so under this file inputs folder, train language.spaCy. So that's the data it's going to use for training. Then for testing, we say path.dev input slash test language.spaCy. So that's the test model. Then the output, we've created a new folder called models here. And when you look at the local machine, we would still be able to see it. We have this folder called models. So that's why we're saying we want the final output to go. So output is model slash sensitive and model. This can be changed, of course. Once we train that, it took almost 1 minute to train. We see some information that is being given. This score is close to an accuracy score, and we can see that it's about 71%. And then it took some few epochs to finish that. And the final model was saved under the sentiment model slash model last, meaning the last model was saved, and also the best model was also saved. And when you look at the models, We have model best and we have model last. So you can pick and choose whichever is performing better. But I normally use the model best for my own evaluation. Then you can evaluate this model using, again, Python with an exclamation mark is a terminal command, remember. Then -m, SpaCy. What do you want to do? You want to evaluate. And the model you want to evaluate is model slash sentiment model under model best, right? That's the model you want to evaluate. And you want to use we want to create an output file, which is called metrics.json. And then the data itself that we'll use for testing is the test language.space. You can have another evaluation data set aside that you can use now for this. And you see now you get a lot of information. You get what which I think it's an F score, and more specifically, you get precision, recall, and F1 score for both the negative and the positive case. In this case, I normally just focus on the F1 score, which is some kind of harmonic mean between the precision and the recall. So we see that the negative is performing slightly poorly. We want this to the closer it is to 100%, the better, but positive is slightly good. Then you can look at the area under the curve. Again, this is quite high. So now with such a small data set, this would be considered a good performance. You'd want this F1 score to be quite high, but of course, the best way to do is to expose it to a lot of data and also do a better cleaning that I've done. I've just done a simple cleaning where we remove the hashtags and then we remove the stop words, and that was it. Now, with this, we've trained a model and we've also been able to evaluate, and we have now the metrics that we've used for both training and testing. Now, sometimes it's also good to have a wild case situation. So we look for some data that has not been exposed to the model, and of course, this would be like some demonstration of what would happen now in production. If we take this model and load it in a production system where now a user can be able to interact with a model, it would be exposed to some sentences, and we want to see how the model perform to these sentences or these tweets. Now we are exposing it to. So I created 3 sentences. Like sentence number 1 is I love this product, it's amazing. The second one is this service was terrible, I'm very disappointed, and I'll complain to the management. And then the final one is the weather today is quite pleasant. And we go through them, use a for loop, we go through the sentence, we clean it, same way we've cleaned the tweets, and then we create a document file so that the space will be able to understand now this sentence. And then we predict what would be the sentiment of this model based on what the model has learned, and then we print that. And we see for the first sentence, it's saying that the predicted sentiment is positive with a very high positive score. The second one is a negative. It's predicted as negative, which is true. The service was terrible. That's a negative. I'm very disappointed. It's also negative. And then the final one is that the weather is quite pleasant, and this is also predicted correctly as positive. So with just a small data set, we were able to create a model that is able to recognize the sentiment of a sentence. Now, what we would do next would be number 1, to expose it to more data so that it's more accurate. And also the reason why we removed the neutral is because you can be able to create a function that can be able, if the positive score, the sentiment score is not so high, let's say it's between 60 and 40, you can say that a neutral score. That's a neutral sentence because the model is not so sure. But for those highly positive or highly negative, you can be able to know for sure the model knows this is positive or negative, but everything else can be neutral. So we've been able to create a model. We've been able to clean from the clean data which were from Twitter, and we've also been able to evaluate that model and come up and be able to also expose it to a real world situation or in production. So moving forward, we'll be able to create more models. We'll be able to add more data to these models, better cleaning, and in the future we can also do some domain or what we can call more specialized natural language processing, like creating a model that is able to do named entity recognition, which is some form of classification but more advanced. So we stop here for now.